Hey guys, in this tutorial we're going to create our own GUI class in our game engine, and we are also going to render our first widget, as you can see here. Please enjoy. Before we actually jump into implementing anything, I want to correct something in the previous video. There's 3 DLLs we are missing that we need to actually copy over. It may actually find these DLLs even if you don't copy them over, if you leave the actual CEGUI folders in your deps folder, but if you ever move it or try to send this to somebody else, it won't work. So you need to copy CEGUI silly image codec.dll and CEGUI expat parser.dll and CEGUI core window render set.dll. You need to copy all 3 of those to the release folder, and then their debug versions, which has the _D, you need to copy those 3 into the release folder, or sorry, into the debug folder alongside your exe with all the other DLLs. If you don't copy those, you might get a crash, so make sure you do that, and let me know if you have any trouble. Thanks. Hey guys, and welcome to the next tutorial for UI in the Advanced C++ and Graphics tutorial series. Today we're actually going to get some UI rendered on the screen, and we're going to add a GUI class to our engine, or whatever your game engine is, so that we can use it in all of our games. And first thing we should do actually is something that we should have done a little while ago. If we go into Engine and go to Properties, and you go to Configuration Properties and then Librarian, what we can do is we can link to our libraries that we need here and set the library directories here so that whenever we're making a new game, we don't have to keep remembering to link everything. I've been making you guys link everything for each game, which is good practice for linking, but you really don't need to do that if you're going to keep using Engine or whatever your game engine is. So let's do that first. Let's go into Ninja Platformer Properties, and what we're going to do is we're going to go to Configuration Properties, Linker, and then Input, and we're going to go here, and we're going to, right now we're in release mode, we're going to take all of these, and I'm going to copy everything including Engine, but I'm going to delete all of them except for Engine from here, and then click Apply, and then when we go to Engine and hit Properties, go to Configuration, Librarian, and then General, Additional Dependencies, we're going to paste all of those here. And we're just going to remove bingen.lib, because obviously bingen isn't going to link to itself. And then we're going to click OK. And then for additional library directories, we're going to edit that. And here we're going to, let's just copy it to make it easier. Go to Ninja Platformer Properties. And if you go to VC++ directories, and then you see library directories here, we use deps lib release for release mode, so we're going to copy that. And that's what we're going to put in graphics tutorials, or sorry, in bingen. So properties. Let's see, Librarian, General, and then additional library directories, edit, and paste that one. Then click Apply, and then let's do the same for debug mode. Yes, save the changes. In debug mode, it's the same library directory except it's debug instead of release for that last folder, so let's change that to debug. Click OK, Apply, and now we just need to copy those dependencies from Ninja Platformer, and now that we've done this, we won't ever have to do it again for any of our others. So we are in debug mode for Ninja Platformer, and we're going to linker, input, do the same thing. We're just going to grab every single one of these, including Bingen, and click OK. Graphics tutorials, or Bingen, properties, and then we go to Librarian, General, Additional Dependencies, edit that, paste it there, delete bingen.lib, and now we're good. Now if we want to, we can go and delete the libraries from the linker for all of our other games. We don't need to. It's okay to duplicate it. It's not going to cause any bugs. Alright, so let's get started on actually making our GUI in Bingen. So what we're going to do is we're going to add a class to Bingen. We're going to go to Add Class, and let's call this just GUI, or GUI, however you'd like to call it. And GUI.h already exists. Yes, I was screwing around with it earlier, and I guess I forgot to delete it. That took a while for some reason. Now when that's done, you're going to first go ahead and add your includes to the top. We're going to have include CEGUI and then CEGUI.h. We're also going to have include CEGUI slash render, I believe it was render modules, slash OpenGL of course, and then slash open or GL3 render.h, that's the one. Now we can make our class, though yours probably auto-generated that. Mine was doing something weird. And inside, this should all be inside namespace Bingen, because this is part of our game engine, of course, our primitive little game engine. Alright, so now we have our GUI class, and we can start actually filling it with stuff. And we'll do public and private. Okay, so the first thing we need to do is we need to give ourselves a renderer. And what we're actually going to do is we're going to be sharing one renderer with all of our GUIs. So say we want a different GUI for the main menu and for the actual gameplay screen. We're going to have the same renderer that actually renders both of those GUIs. So to do that, we're going to use a static renderer for that. So we're going to say static CGUI and then OpenGL3 render. And we're going to make this a pointer, and we'll call it just mRender equals null pointer. We're going to start it out at null pointer, and actually we can't do that since it's static. We have to initialize it in the CPP file, so let's go ahead and do that. I'm going to grab this, go into the CPP file, which should be including GUI.h, and we're going to declare it here, and we're going to say that this belongs to the GUI, so we're going to say GUI mRender, and we're going to initialize that to null pointer. And we want to make sure that we only initialize this one time, and it should actually be Benjin GUI. Alright, so now we need an init function and a destroy function. We're going to say void init, that will initialize the GUI, and we're going to say void destroy, that will destroy the GUI. So let's see, what else do we need? We'll just start with this for now. I'm going to go to Visual Assist and create method implementations because I like to cheat. Alright. And that did something weird. I'm going to copy this up here. Okay, so for initializing, first thing we want to do is check and see if the renderer has been created. If the renderer has been created, that means that we have also initialized the system for CEGUI. We only actually need to do this once. So if we call Benjin GUI init multiple times, it should only happen the first time that it actually sets this renderer up. So we're going to check that. Let's say check if the renderer and system were already initialized. And we're going to say if mRender is equal to null pointer. And if that's true, then that means we need to initialize it. We're not already initialized. And to do that, we use the function we called before, and I guess I should tell you that I deleted the includes in gameplay screen.h for the CGUI, and I also removed that line that we had that was just a temporary line to check to see if everything worked that was calling this render initialize. So make sure you do delete that. But the line was CEGUI : OpenGL3 render, my renderer equals bootstrap system. That's what we used. So instead we're just going to say my renderer equals CEGUI : OpenGL3 render : bootstrap system. And this actually returns a reference. So what we're going to do is, since we're using a pointer here, we're going to set it to the address of that variable. So that's going to initialize our render as well as initialize all of the CGUI subsystems. Now the next thing we need to do is actually work on our resource provider. And what that does is it allows us to load all the resources that we have specified. Let me pull up our folder here. Here I am in Ninja Platformer. You remember we copied everything over into this GUI folder. We have a bunch of resources here. What we need to do is we need to tell the CGUI resource manager that all of these folders are here, and this is where they can find all the fonts and images and layouts and all that stuff. So we're going to have a few lines of code here. What we're going to be doing is we're going to get the resource manager. We're going to say CEGUI default resource provider. And this is basically what provides all the resources for us, obviously, and this is what we are going to point to the resource folders. And we're going to get a pointer. We're just going to call this RP for resource provider, and we're going to be getting the CEGUI system : get singleton. Now get singleton, what this does is it gets basically a global system object. There's only one system object, and get singleton returns this. If you want to Google it, it's called the singleton pattern. It's generally not a good idea to use the singleton pattern, but it works fine for CGUI, so they're using it. Anyways, get singleton is going to return that object. If you mouse over it, it should tell you what it returns, and it actually returns a reference to CEGUI system. And we can call dot get resource provider. Resource provider. And that is going to return a CEGUI resource provider. And since we are casting a resource provider to a default resource provider, we should also do a typecast so it's not going to give us any errors. Now this is the typecast I've taught you, the one you're familiar with, and that should be a pointer. This is the one you're familiar with. This is actually an unsafe typecast because if you can't do the typecast, the compiler is not going to give you a warning. It's probably just going to crash at runtime. An equivalent of this that is actually safer is what's known as static cast. So we're going to do that. We're going to say static cast, and this has no overhead. It's just a little bit harder to type. And we put our type in here. So we're going to say CGUI : default resource provider. I'm just going to copy it because I'm so bad at typing for some reason. And there we go. default resource provider pointer, and then in parentheses we put the thing we want to cast. Now this is a huge ugly line of code, but it's much safer because if we can't actually cast resource provider to default resource provider, the compiler will complain to us and then we'll have to fix it, which is much safer than it just randomly crashing at runtime and you having no idea why. Okay, now we have that handle, so now we can actually start setting our resource directories. So the first one we're going to set, let's go ahead and set the image sets one first. This is going to have all our images. If you click on here, you can see a bunch of JPEGs and PNGs. This is a bunch of stuff that was included with GUI, and we can actually create our own image sets as well and set those up. But for now, we're just going to use the defaults. So what we need to do is set this image sets directory, and it's inside our GUI folder. And what we're going to do is we're going to, right now Bingen is, we haven't passed in a directory. We should actually probably pass in a directory and tell it what resource folders we should be using. And since we're using the same resource folders for the entire game, this is only going to really matter the first time we call init. So we need to make sure that whenever we initialize our GUI, that we are doing it, really we should probably make the init function a static function, and we only need to call init one time instead of multiple times. That probably makes it a little bit safer. So what we're going to do is we're going to go ahead and do that. So we're going to make init static. So now we can call it without even having an object, and that'll just initialize all the subsystems and the resource provider and all that. We're going to pass in std string, and I'll make it a const std string so we don't do a little copy. And we're going to say resource directory. There we go. So that's going to be the file path of the resource directory, and copy that, put it in here. There we go, and we're still going to keep this check here just in case they call it twice. And what we're going to do is we're going to say rp.set resource group directory, and the type of directory it's going to be is it's the image sets directory. This is for all of our image sets, and the folder it's going to be in is resource directory plus, and then we're going to say /image sets / like that. So we're going to pass in, for instance, GUI as the resource directory for our game, and it's going to take GUI and concatenate it. This plus concatenates two strings or adds them together with /image sets, and that's going to do what we want. And now we can just copy paste this. We're going to do this for all of our different resource directories. We need 1, 2, 3, 4, 5, 6 of them. We have schemes. And a scheme is basically a method for determining how a certain object should be built. Like there's a scheme for buttons, there's a scheme for windows and things like that. It just says what renderer to use, what textures to use, all that stuff. So this will be schemes, oops, copied that, schemes, and then we have fonts, and that will be fonts here as well. Then we have layouts. Layouts will go here. And we have look and feels, and look and feels goes here, and look and feel is just sort of a layout kind of thing. And then image sets, we have Lua scripts instead. Let's see, Lua scripts, and Lua scripts goes here. So that's going to set all of our resource directories, which is nice. Now we need to tell each of our little resource managers what resource group to use. So we have a resource manager for image sets. We need to tell it to use image sets. We have a resource manager for schemes. We need to tell it to use schemes, all of that stuff. So let's do that next. And these are all pretty much global singleton objects, image manager. These are actually static objects, I believe. And we're going to say set image default resource group for the image manager. We're going to set this to image sets. It doesn't have to be image sets, but it should be the same as whatever you set right here for the default directory for image sets. Alright, so we have that one. Now we need, what's next? Schemes. So we're going to say scheme, : and this is going to be set default resource group for that, and this is going to be schemes. I hope you see where this is going. It's actually pretty simple how this is all working out. Now we need the font. We'll do fonts next. And then we're going to say set default resource group again, and this time it's going to be fonts. Now we need, what's next? Widget. This is called the widget look manager. This is what does the look and feels. And we're going to say set default resource group again, and this is going to be look and feels. There we go, and we're almost done. Next is the window manager. set default resource group, and for this one it's going to be layouts. And finally, we need to do the script module, C's UI script module for any scripts we have, script module. Set default resource group, and this is going to be Lua scripts. And these should match all of the ones we set right here in the name. Okay. So now that that's done, we've pretty much set up our resource directories, and we've actually set up the render and everything, so we're good now. So what we can do is actually create ourselves a GUI and initialize it and make sure it doesn't crash, and then we can actually start creating ourselves some controls and adding a render function and all that. So let's go to gameplay screen, and let's go into the header file here, and I'm going to include bingin slash GUI.h. That shouldn't give me any errors, and now we can create ourselves a GUI in our gameplay screen. Bingin ::GUI, and we'll call this mGUI. Now in the on entry, I'm going to actually initialize this. Now since the GUI initialization is static, remember, it really doesn't matter if we call mGUI.init or just bingin GUI.init. I'm going to do bingin GUI.init just because it's a little bit more clear that we're calling a static function. Either one works. Our resource directory is of course GUI, and this will initialize the UI. There we go. And we just need to make sure that we call this after we've already initialized all of our OpenGL stuff. And we did already initialize the OpenGL stuff at this point, so we don't have to worry about that. And by OpenGL stuff, I mean like glue and our rendering context and our window and all that. That's all initialized at this point. Alright, so that's going to initialize the GUI. Now we need to actually work on loading some assets and then rendering them. So let's go back into GUI.h. Let's go ahead and, while we're remembering it, let's write a void draw function that's going to draw our GUI. And now also we need to actually have a specific GUI context. Now each GUI is going to have its own context, and each context holds different sets of controls. So you're going to want to have different buttons for the main menu, for instance, than you're going to want for the actual gameplay. You're going to have different controls for that. So what we need to do is store that context. So we're going to say CEGUI, and we're going to say GUI context, and we'll make it a pointer, and we'll just say mContext equals null pointer. And let's go ahead and write some getters as well for the render and the context. Or we could actually just make these public. It really depends on if you want them to be able to be set. I'm going to just write getters. So we're going to say CEGUI, OpenGL3 render, get renderer. And this can actually be static because our render is static. And this is going to return mRenderer. Now this is the same as having a global renderer, so I'm not really doing anything important by making this a getter right now, but it's not really a big deal. It should be a pointer. And let's also do the same thing with the context. So we're going to say context, and we'll just say get context in case we need it. And we're going to return mContext. And we should also have const versions of these, or we should just make it const. If we don't think they're going to modify this context directly, we can go ahead and make it const. And if we decide that later on they are going to be able to modify this, we can make it non-const, or just make it public, or just add some functions where we need them. Okay, let's just say getters. Alright, so we have the draw function. Now we need the ability to actually load a specific scheme. Now I'm going to go ahead and open up our folder here again, and go into GUI, and let's go into schemes. And you can see there's a bunch of schemes here. One that's they used in the documentation as the for the little tutorial is the Tazerac look, and it's a pretty cool one. I also like the Alfisco skin one. Each of these is basically a different layout, a different look for the UI. So you can actually use a bunch of different schemes here. We have like a Windows look if you want it to look kind of like an old Windows style. A lot of these really aren't very good, and a lot of them aren't complete. You can create your own. For now, I guess we'll just use Tazerac look. Maybe we can switch it up later. Now if I open this in Notepad, you can see there's a bunch of stuff here. We have, this is an XML, and it has an XML loader built in that will load all this stuff. And you can see we have like a label, a button, a checkbox, image button. We have all these different things that we can create. what we want to do is load this scheme file so that we can create all these different objects. So to do that, it's actually really simple. We just need to write a function that's going to do that for us. And the function is going to be like basically a load scheme function or something like that. So let's go ahead and do let's make it a void function for now. And we're going to say load scheme. There we go. And we're going to pass in const std string. And we'll say scheme file. And this is going to load ourselves a scheme and allow us to use it for getting all sorts of different kinds of buttons and widgets and things like that. So let's go ahead and take both of these and put them in the CPP file and implement them. And we should put binge and GUI before both of these. Okay, now loading a scheme is actually something that's really easy to do. You just call CEGUI, scheme manager, get singleton again because this is a singleton object, and we're going to say .create from file, and we're just going to pass in the file name. So we're just going to say scheme file like that, and that's going to go ahead and load our scheme. It's really simple. And now that we've loaded that scheme, what we can do is we can use it to create all sorts of different widgets. We can use different layouts, and we can get like mouse arrows and windows and all sorts of stuff. So not only do we need a scheme, we need to be able to set a font. So we're going to say void set font, and we're going to say, let's do font file. Let's put that in as well, because if we don't have a font, we're not going to be able to actually render any text, of course. Alright, and the font is also really easy to set. We just say context set default font, and we're going to pass in the font file here. And that'll set the font for all of the widgets of this context. Now we never actually created the context for this, I realize. So we have the context handle here, but we need to create it. And this is something that we will create in the init function. So really maybe this shouldn't be static. We could either have a static init function and then another init function that initializes the context, or we could just assume that whoever's using this library is smart enough to know that you can only have one resource directory for all of your context. So I guess we'll just do that. We'll make it non-static again. And then in here, outside of the mRenderer thing, we're going to create our context. So we're going to say mContext equals CEGUI : system : get singleton dot create GUI context. That's going to create our context. Now we also need to give it a renderer. And what we're going to do is we're going to say my render, not my render, we're going to say, what's our render? mRender dot get default render, or arrow get default render target. And that's going to set it up so that our context can render using our render. Now this returns an object, not a pointer, so we just need to get the address of that. And now that I've made this non-static in the gameplay screen, I need to call mGUI.init. That'll fix that. Alright, so now we have a context and we can actually call these set fonts and things like that without having any problems. Now let's create a way to actually give ourselves a widget. Now in CEGUI, widgets are all windows. They all inherit from the window class. And we have buttons, we have labels and things like that. They all inherit from this same class. And the way it works is you create a widget using one of these schemes, like if I open up our file again, let's pull it over here. Here's our Tazerac look.screen. If we create one using the Tazerac look.button, it's going to use a push button type. You can see it says CGUI push button. So whenever we return the window for that, we're going to cast it to a push button. We're going to use that static cast to turn it into a push button. And you can also see what render it's going to use. It's going to use the button render. You can see what look and feel it's going to use and all that. So you can come in here and screw with all this if you want to change how things work. Alright, so what we're going to do is we're going to write a function that actually returns one of those windows for us that uses a specific scheme for actually generating the window. Alright, so what we're going to do is we're going to make it return a CEGUI : window, and it's going to return a window star, and we're going to say create widget. Now, what it needs is it needs two things. It needs a scheme, and it also needs a name. If we don't have a scheme and a name, it's not going to have any clue how to actually render this thing or create it, or what kind of object it's actually supposed to be. So we're going to say const std string scheme, and then we're going to also say const std string name. And what we can actually do is we can use a default parameter for name that is just an empty string, and if we don't give it a name, it'll just use a default name. It's usually a good idea to give it a name so you can look it up later, but you don't actually need to if you don't want to. So that's why I'm making that a default parameter. Alright, so create widget, we're going to copy this into the CPP file, and this will go, where is it, below draw, below load scheme. There we go, and in the CPP file we don't redeclare any default parameters, so I'm going to comment that out just so you can see that it's a default parameter, but it's not getting redeclared. Okay, now to actually create this, what we do is we call the window manager.create window. So we have to actually get the window manager. We're going to say CEGUI : window manager, window manager, : get singleton, and then dot create window. And we're going to pass the scheme. And it's called type, so just to be specific, I'm going to also call this type just so it matches up. Type, there we go. Type and then name for the next parameter. Alright, that's going to create it, and then we just return it. Easy as that. So that's going to always return a type of window star, so you just need to look at the type you're passing in for creating this widget to determine what type of widget it is. For instance, if we were to use the button Tazerac look widget, it would be a push button type, so we're going to want to cast it to a push button when we actually return it. And actually what we want to do is when we create this widget, we want to also add it to our view. This is going to create it, but it's not going to allow us to actually render it. And to do that, we need a default root window. And what we're going to do is we're going to store that root window. So we're going to say CEGUI : window star mroot. This is the root window equals null pointer. And in the init function, we're going to create this. So we're going to say mroot equals, it's going to be again CEGUI window manager : get singleton, and then dot create window. And for this, we're just going to call the type, it's going to be default window. This is what you use for the root. And for the name, we'll call it root. Then we need to set the root window. We're going to say mcontext.set root window. And we're going to pass in mroot for that. And we don't need the address of mroot, we can just say mroot because mroot is a pointer already. There we go, and now that we have the root, we can actually add different widgets to this root, and then they will be able to be rendered, because it's always going to render starting at the root. So instead of returning this directly, let's go ahead and create an intermediate pointer, window star new window equals, and we're going to set it equal to this. And then what we're going to do is we're going to say mroot add child of new window, and that's going to add new window to our root so it can be rendered and it can receive input and all that good stuff. Then we're going to return new window like that. Now we also need to be able to set the position of the window, and we need to be able to set the dimensions of the window. And doing that with CGUI is kind of ugly because what it allows you to do is it allows you to specify dimensions and positions as both a percentage of the parent. So for instance, if you were to set it to be 100%, then it would be the size of the entire window. If you were to set it to be 50%, it would be the size of half of the window. And it also lets you set it as pixel offset, so we can actually tell it exactly how many pixels it needs to be. And what it does is it actually can combine both of these things. It can use both at once. Now we could force whoever is calling this create widget function to set it on his side, but that's a lot of ugly code. Instead, what we could do is we could allow them to pass in the dimensions optionally for this, and that's probably what we should do. That makes it a little bit easier. And then later on, if they want to, they can manually change the dimensions pretty easily using their window handle. So let's go ahead and pass in some stuff. So we're going to say it's going to be float, and we'll say X%. float x pixel, float y percent, float y pixel. So this is going to set the position, and then we also need not only the position, but we need the dimensions. So instead of having 4 floats, what we could do is we could use our desrect thing that we're familiar with using. We can say F32, or sorry, we need glm vec4, and we'll make this a const glm vec4. Desrect percentage and desrect pixels. And then desrect pixels, like that. And we don't have glm, so I'm going to include that. Include glm.hpp, and I think it's lowercase glm, I guess. Doesn't really matter. glm. That should stop complaining now. There we go. So we can pass in 0 if we don't care for these desrects, or we can pick one, or we can actually use both and it will combine them. It's pretty cool. So let's see how we do that. I'm going to copy this into the CPP file for create widgets, and we need another comma there. Alright, so now what we need to do is we need to call first set position, new window, set position, and it takes this weird CGUI u vector 2 thing. So we're going to say CGUI : u vector 2. And then inside this, it takes 2 parameters that are both CGUI udims. This is why it's really ugly to actually initialize this. It's a bunch of code. So we have udim and then another udim. These are the udims for the x and y. And a udim takes first the percentage and then the pixel. So we can say desrect percentage dot x, and then desrect pixel dot x, like that. And what's the problem here? Desrect, what's wrong here? Oh, I need a comma. So we have percentage and then pixel for x, and then we need the same thing, percentage then pixel for y. There we go. And now we need to, I'm going to copy this, and we need a set dimensions, which is set size. And instead of x, y, we just do zw, since we're using a destination rectangle like we do with Sprite Batch. There we go, and now we've moved these horrible lines of code into create widgets, so we don't need to call them elsewhere. And this should be not uvector2, it should be usize, which takes the same parameters. There we go, that's nice. And just to make our lives easier, what we can do is if we want to set a widget, our widget's dimensions, we can call a little helper function that we create here, static set widget desrect, or something like that. And we'll pass in the widget, and we'll also pass in these, desrect perk and desrect pix, just to make it much easier to actually set these rectangles. And what's the problem? Static void. Copy this into the CPP file. There we go. Belongs to Benjamin GUI. And we're just going to copy these 2 lines right here, except we're going to use, and I didn't give it a name, widget. Put that in the CPP file. Widget. There we go. So we're going to say widget set position, widget set size. That'll just make it a little bit easier for us so we can kind of move these ugly lines of code in here so we don't have to know how they work. We know how desrects work. It's much easier to reason about that. And what we can do is, so we're not duplicating code, we can just call this function, set widget desrect with new window and desrect perk and desrect pix. And then we can delete these, make it a little bit cleaner. And alright, so now we have the ability to create a widget with a position. We can get that widget returned to us. We have the type, so we know how to render it. Now all we need to do is actually render it to the screen. And let's go ahead and, for safety's sake, let's also implement our destroy function. And what that's going to do is just destroy our context. We just call CGUI system get singleton dot destroy GUI context, and we'll just pass in mContext. Now mContext is a pointer and it wants a reference, so we're just going to dereference that with the star, dereference operator. Asterisk, whatever you want to call it. Alright. Now last thing we need to do is draw it, and then we can actually start building ourselves a little test UI. Now to draw it, there is one function we could call that's like CGUI, render all GUI context, but that's going to render every UI that we have. We don't want to do that. We want to manually render the specific GUI context that we are using for this particular UI. And to do that we call CGUI : system : get singleton, this huge line of code that's always so annoying. What we probably could do is have a static handle to that so we don't have to keep calling it, but whatever. And we're going to say get render, and actually we don't need to call get render since we can call mrender, and we just call begin rendering, and we call mrender.end rendering, sort of like how sprite batch works, and then we call mContext draw, and that'll draw the entire context. Now there is a bug here. I'm not going to tell you what it is yet, just because I want to show you to do a bug here, because I want to show you what happens. It's a pretty brutal bug. But for now, let's go ahead and just start creating some UI and see that it actually works. So here we init the GUI. That's good. And let's actually init it at the bottom. Oops, there we go. Init the GUI. So now we can start adding controls. So let's go ahead and create a button using our Tazerac look scheme thing, and let's use Tazerac look button as the style for that. So we'll say mGUI create widget, and we're going to say, I'm just going to copy it from here, we're going to say Tazerac look /button. And for the destination rectangle, we're going to say glm vec4. Now let's just use percentages. So the x percentage, let's put it in the middle, and for the y, let's put it in the middle. And for the size, let's make it 10% in the x direction, and like, I guess, let's do 1%. No, let's do 5% in the y direction. It should be an F. And for the desdirect pix, don't care about pix. I like it to be relative, so I'm just going to say 0. And for the name, let's call it test button. There we go. All right. Now that we have this widget, we should actually get a handle to it if we want. We could get a handle to it, or we could get the widget later. For now, let's just create it and not worry about it. We'll obviously amend that probably in the next tutorial. Now that's going to create the widget. Now we just need to draw the GUI. So what we need to do is copy this and go down to draw. At the very bottom, you want to do your widget last, and or your GUI last. We're just going to call it mGUI.draw. All right. Now let's see how many errors we get. I'm going to run it in debug mode and see if anything bad happens. Hopefully it'll work the first time. And no, we are getting cannot open input file OpenGL32.lib. Give me just 1 second to figure out what's wrong here. Okay, while fixing this, I found a couple issues. First, let me show you why it was crashing. So if I go to, or why it wasn't building, if I go to the Benjamin properties and then go into librarian and then C++ directories. Right now I'm in debug mode. If I go to library directories, here it has this library path. That wasn't there before. For some reason, it was not inheriting the parent project defaults here. You have this Windows STA library path, x86 here, that's being included. This is what has OpenGL32.lib in it, and for some reason it wasn't there, so I fixed that. So if you have that problem, make sure to do that. And of course, if you're not on Windows, you're going to have something different entirely. If you can't figure out how to get it so that OpenGL32.lib will link with this, then you can always, of course, link it with just the main like zombie game or ninja platformer projects as well as a last resort. So also another problem I had that I just forgot from the last tutorial, in the librarian, if you go to additional dependencies, make sure you do have CGUI base 0d.lib and render.d.lib. I forgot to copy those over from the last tutorial. This is in debug mode, and then in release mode you should of course have the non-D versions. So make sure those are in there, and then it should be able to run. Now when I do run it, I get some crashes because if we go to, let's go to GUI.cpp, here there's actually a problem. It's our resource directory for look and feel. We call it look and feels, but it's the directory is not look and feels plural, it's just look and feel. If we don't do that, we'll get a file IO exception when it tries to find that folder and it can't find it. And also in the set font here, we're setting the default font, but we're not actually loading the font. We need to, of course, load that font. If we don't load the font, we're going to also get an exception there because it can't find it. So to load the font, it's actually pretty easy. We just call CGUI : what is it, font manager, and then get singleton, and then .create from file, and here we're going to pass font file, and we're going to add a .font to it. When we load it, we use the .font, but when we set the font, we don't use the .font, which is why we have to add this .font. And now we'll be able to actually load that. Now another problem was in gameplay screen, we weren't actually setting the scheme or font, so let's do that. Here after GUI.init, let's first set the scheme, so we're going to say mgui.set or load scheme. And the scheme that we are going to load is the Tazerac look scheme. I just copied this from the file. There we go. Tazerac look.scheme, that's the one we have decided to use for now. And we also should set a font, so we're going to say mgui set font, and one of the fonts in the font folder that works decently well is this Deja Vu 10 font, so we're going to do that one. Deja Vu Sans 10. And that will load if we open up the font folder. I'll show you which one it's loading. Here's fonts. It's going to load this Deja Vu 10 .font here in fonts. Make sure you don't include the .font when you call set font. And now that's going to load it, so when we run it, we shouldn't get any crashes or anything like that, any file I/O exceptions, but I may have forgotten another thing to fix. There we go. Okay. Now you're going to notice this is doing something totally insane and scary, and this is the bug I was talking about earlier that took me a little while to figure out what exactly was going on. But let me show you. Oops, this is the wrong project. Let me show you something kind of cool about this. If we switch from button to, let's open up our Tazerac look thing. If we use frame window instead of button, this doesn't happen. So if we say frame window there and then we run it, then we don't get this crazy flickering with the button. And there you can see it renders our little frame window there, which is all well and good. So why was it screwing up for the button? Well, the answer to that question is it's because whenever it's rendering buttons and labels and a lot of widgets, it's using what's known as what's called the GL scissor test, and it uses that to discard certain pixels that are outside of a rectangle. So it's like discarding pixels that are outside of the rectangle for the button. So what we need to do to easily fix that is in the GUI.cpp, after we render it, we need to manually disable it. We're going to say GL disable GL scissor test. And this is just something, I guess, when the people were writing the OpenGL renderer for CGUI, they forgot to do that. You can't always trust their code to be the best. So this will disable that, and this is the only bug I've found with the renderer so far, but there could very well be other bugs. Just a warning. I haven't really been using CGUI much. Traditionally, I've been writing my own UIs, but of course we can't do that in this tutorial. It'll take forever. Okay, so now that we have that, we can use button again. So where are we? Here we go. Button. And now we can have a button. There we go. So when I run it, we should have a button that's just kind of in the middle of the screen. And there we go. There's our little button. It's kind of a crappy little button. It doesn't look very good. Let's go ahead and give it some text as well. Let's go ahead and see if we can give it text. So I'm going to go back here. Now to do that, we should get the handle. So this is going to return a window, but we're going to cast it to a CGUI push button. Because remember, this button class returns a push button. Button, we'll call it test button, equals and mgui.create widget, and of course it's going to give us an error because we're not casting it, so we're going to use that static cast of push button star. There we go, and put all this in parentheses. So now we have a push button handle with this massive line of code here, and now we can give our test button some text and see if it renders that Deja Vu Sans font. So we're going to say test button.set text, and let's set it to hello world, just because why not. And now when we run it, we should have that button saying hello world or a crash, one of the two. There we go, and it says hello world, and it's actually pretty good quality font. Now the actual button itself doesn't have a very good quality, but you know, it's not bad. So let's go ahead and try a different look and feel so I can show you how to use a different one. So instead of Tazerac look, let's try the what is it? Alphasico skin. Alphasico skin is almost as complete as Tazerac. I think Tazerac has a few more options than Alphasico, but all we got to do here is just change Tazerac look to Alphasico skin, like that. And we can actually load two schemes at once. We can load the Tazerac look and we can load the Alphasico skin, so we can pick between them if we want to. So there's the button for Alphasico skin. Let's see how that works out. See if it looks a little bit better. Now, yeah, I think that one looks a lot better, honestly. I like the Alsfico skin. It's a lot cleaner. It's not as pixely on the edges. So we can't click on the button. We can't mess with the button or anything. That's what we're going to learn in the next tutorial. We're going to learn how to do input, and we're going to learn how to actually make a functioning UI with some events and things like that. And we'll probably go ahead and make the main menu in the next tutorial as well. So thanks for watching, guys. I hope you learned something, and feel free to work ahead, those of you who are just watching the tutorials as I upload them. Bye.